In this video, we are going to discuss a problem asked in IIT Advanced 2022. Problem is based on angular momentum. The problem is that a flat surface of thin uniform disk of radius r is glued to a horizontal table. Another thin uniform disk B of mass m and width of the same radius r roll without slipping on the circumference of the as shown in figure. A flat surface of B also lies in the plane of the table. The center of mass of B has fixed angular velocity omega about the vertical axis passing through the center of A. The angular momentum of B is n into m r omega square with respect to the center of A. Which of the following is value? क्वेश्चन ये है, इसमें एक डिस्क ए है जिसे एक टेबल पर चिपकाया गया है, दूसरी आइडेंटिकल डिस्क है जो इसकी सरकमफ्रेंस पे प्योर रोलिंग कर रही है और इसकी एंगुलर वेलोसिटी ओमेगा दी गई है जो एक एक्सिस के अबाउट जो ए के सेंटर से पास होती है और ए के प्लेन के परपेंडिकुलर है. वी हैव टू कैलकुलेट द वैल्यू ऑफ एन. हियर एंगुलर मोमेंटम ऑफ दिस डिस्क बी अबाउट दिस एक्सिस इज गिवन एज n into m into omega into r square. Okay, let the velocity of the center of mass of disk B about this axis is given as B. This is basically B. Okay. Since this radius is R, so we can write omega dash will be equal to B by R. This distance is R, this distance is also R, hence this complete distance from the center O to the center O dash will be equal to basically twice of R. Hence, since the angular velocity of this disk about this axis is given as omega, so we can write V will be equal to twice of R multiplied by omega. Okay, if we put this value of P here, we can say that omega dash will be equal to twice R omega divided by R, or that comes out twice. That is, we can say that the angular velocity of this about an axis passing through O dash and perpendicular to the plane of the disk is omega dash, where omega dash is equal to omega. We want to calculate the angular momentum of this disk about the axis passing through O and perpendicular to the plane of disk A. Okay, the angular momentum L will be equal to angular momentum about the center of mass of this disk plus mass of the disk multiply by velocity, linear velocity of the disk about point O multiply by the distance, that is O dash. LCM can be written as I multiply by omega dash plus that can be written as M into V into twice of R, because O dash is given as twice R, and simply we can write L will be equal to the moment of inertia of the disk about an axis passing through its center of mass and perpendicular to its plane will be half mr square, that is half mr square into omega dash. Omega dash is given as basically twice of omega from here. Okay, plus m multiply by v multiply by 2r implies that we can write L will be equal to mr square omega plus m into, on putting the value of v is given as twice r omega, 2r omega multiply by 2r or that comes out to be mr square omega plus 4 mr square omega, or we can write L equal to 5 mr square omega, which is given as here n into m into r square omega. From here we can say that implies that n will be 5, hence the correct answer is B here, that is n into 5.